We are in Algebra 2, Lesson 3-5, Factoring Perfect Squares. Today's date is Tuesday, October 6, 2020. Who's reading our objective for the day? Jade is first.
Factor perfect squares in the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared.
Yes, so notice that the only difference between those two, one of them has a plus in front of the 2ab, the other one has a minus in front of the 2ab. Otherwise, they're basically the same. All right, so show me that you know how to unsquare, aka take the square root of each of these. I did the first one for you. If I have x squared, oh yeah, perfect. If I have x squared, I take the square root, I turn it into x, and this is from yesterday. 16p squared. If I take the square root, it turns into what, Jenny? 4p, there it is. What about 64y squared, Jade? 8y. M squared, Charles. 49x to the power 4, Josie. The power of 2, yeah, you divide it by 2. 4a to the power of 6, Andres.
2a to the power of 3.
There it is. What about 16c to the power of 50? Someone new, maybe? Someone new? New? Cohen? 4c to the power of 25. Thank you. All right, so we know how to unsquare things. We know how to take the square root. And just as a review, the way that we say that is we're going to do what to the coefficient? It's kind of repetitive here, but what do we do to the coefficient? How do we get from 16 to 4? What is the operation that we do? Charles? How do we get from 16 to 4? What do we do? Yep, so it's kind of repetitive, I know. Square rooting, you square root the coefficient, and you do what to the exponent? You do some operation by a certain number. What do you do to the exponent? How did you get from 50 to 25? Jose?
Divide by 2.
Yep, divide the exponent. Oh, I can't spell. Divide the exponent by 2. There's your shortcut from yesterday. All right, so here is your fancy formula. The hardest part about factoring a perfect square is knowing that it's a perfect square to begin with. If you know that it's a perfect square, then here's the formula. So if you can identify this form, then it turns into this. It turns into a plus b quantity squared. A plus b quantity squared. And you can probably take a guess, since this one has a minus sign, the next formula is going to be what? What?
A plus b.
Ooh, not quite. It's going to be a perfect square, so it's going to be something squared. What's going to go in here?
A minus.
A minus b, there it is. Those are the only two differences. One's a plus, one's a minus. And the only thing that's going to affect is one's a plus 2ab, one's a minus 2ab. But Mr. Sindel, how do you know if it's going to be like an a squared plus 2ab plus b squared form? And that is the hardest part. I'll go through some examples with you. I think until we hit the backside, you're not going to be able to see what they look like. But let's update our procedure. So yesterday our procedure was always do this first step, and then we had 2 paths. Now we're going to have always do that first step, and then we have 3 paths. Again, if you have no idea what to do, just do Advanced Ninja Star. You'll get the job done. I don't know. Did I ever show you guys how to do Advanced Ninja Star yesterday? I don't think I did. Darn it. I'll have to go back and redo that. Okay, this procedure. Factor out the what? What's always our first step? Always, Fernando. GCF. And I think everyone's, no, Sergio, I still have him left, right? All right. In a quadratic trinomial, again, a quadratic trinomial, I'm just going to make one up from yesterday, x squared plus 5x plus 6. That is a quadratic trinomial, quadratic meaning the highest coefficient, or sorry, the highest degree of the exponent is 2. And trinomial meaning 3 terms, 1, 2, 3. Sergio, what do you use on a quadratic trinomial? Ninja Star, that is. And typically we'll say Advanced Ninja Star just in case. Advanced, because you're right, you could use Ninja Star on this one, but Advanced Ninja Star will get the job done every single time. Ninja Star. Okay, if it's a difference of squares, again, like, I don't know, 49 minus x squared. If you see something that's a square minus another square, you're going to use this a squared minus b squared formula that someone is going to read to me right now, either from your notes or from your memory. Charles.
It would end up as 7 plus x.
Oh, you're going to do it for us. Yeah.
7 plus x by the quantity of 7 minus x.
There it is. Yeah, you factored this one already. Perfect. Charles gave us the answer for that example. Can someone give me the general formula? Wyatt?
A plus b times the quantity of a minus b.
There it is. Nice. And then finally, if you have perfect squares. So let me give you your first taste of what a perfect square would look like. I'll basically, I'll use this one and kind of modify it. So it's going to be 49 minus x squared. Oh, it looks the same, but there's a middle term. The middle term is going to be square root of that, 7, multiply by half of that, or square root of that, I guess. Square root of x squared is x, going to be negative, so negative 7x. And then I have to double it too. Dang it, I forgot about the 2. So double it, that's going to be negative 14x. So if you might not have caught that, but what I did in my head just right there was this. I took the square root of a to get to a. I took the square root of b to get to b. Then I doubled it. That's how I got that middle term. That's how you can verify the middle term is indeed making it a perfect square. We'll go through that more later though. And if you do have perfect squares, you're going to use one of those two formulas, and I am going to be a little bit lazy in my notes. I'm just going to say see above. All right, so we have our pathways. I'm making these pathways, again, as the most efficient way to solve these problems. But if you are ever stuck and you just want to memorize one thing and be done with it, memorize Advanced Ninja Star. There you go. It'll work. And I promise I will actually show you how it's done today. Okay. Example number 1. The square below has an area of x squared plus 8x plus 16. What expression represents the side length of one side of the square? It's a square, so this side and this side are the same. Just tell me one of the sides, and you've really told me both of the sides. So this is the hard part now. How are you going to move from here? And it is a perfect square. I've told you that. Sometimes I don't tell you that, and you have to verify it is a square. But it is a perfect square. How do you get from this multiplied out form into the factored form? And you don't need to give me both of them, because you just need to give me one of the sides, not both of the sides. What do I do? One hand, two hand. Only 2 people have an idea of where to start. Charles, talk to us.
Well, the first one is not going to be that.
Perfect.
In this case, it would be 1.
Okay.
The first one is only 1. And then up top, with the so then it should be, I believe, 1 plus 16.
1 what?
Which one is the A term and B term?
That's a great question. Let me zoom into the formula and analyze this a little bit before you answer. So this is for everyone. Again, the question is, how do we get from here to here? So if we can assume, yes, we have a perfect square, this is a perfect square, then I'm going to square root the first term, put it here. Square root the second term, put it here. Copy down the symbol in front of the 2ab and put it in between. Again, I copied down that symbol, that's why that turned into a minus sign. So that 2ab term, we don't care about it aside from the fact that make sure that it is indeed a perfect square. We don't really use it once we write out our formula though. So square root first, square root last, copy the sign.
Square root the first term, which would be 1 square root 1, 1x, right?
Yep.
So that would be x in the beginning. And then for the last term, square root of 16 is 4. And it should be x plus 4.
Yep.
20 squared.
You are correct that if I were to factor this thing, the correct answer is x plus 4 quantity squared. Unfortunately, this one is only asking for one of the side lengths, so we can just say x plus 4 and you're done.
Oh.
Yeah, you're a step ahead. And again, where did that plus come from? This plus came down here. Nope, don't use it. Aside from verifying, and we should, like this is how you would verify, right? All right, you take the square root of x, square root of 4, or square root of 16, square root of x squared, I should say. Multiply these together. X times 4, 4x. Multiply by 2, it is the middle term. We got it. Jade.
If it were x squared plus 8x minus 16, would you take the negative?
That is not a perfect square. That you'll have to factor with Ninja Star. In fact, that one does not factor with Ninja Star, I don't believe. So you'll have to use quadratic formula on that one. Yeah.
Can you also have the answer as 4 plus x, or does it have to be x plus 4?
4 plus x is also fine, yeah, because x plus 4 is 4 plus x. But if I had x minus 4, and I'll write this off to the side because this is something that hung up a lot of people yesterday, got a little bit of confusion. X minus 4 is not the same thing as 4 minus x. You could say, though, x minus 4 is equal to negative 4 plus x, if you want to switch around the order. Good questions, guys. Let's continue on. All right, example number 2, we're going to factor, spoiler alert, every single one that I'm going to be giving you today is a perfect square, but we should practice verifying it too so you get in the habit. All right, first step. Always your first step is to do what? Someone, yeah, Jade.
Factor out the
What is a GCF?
1.
1, yeah, you don't have to do it. All right, now that we factored out the greatest common factor, I need to actually use the formula. Let's verify, though, that this is a perfect square. Let's do the square root of the first term. Help me out. Square root of 49. Square root of 49. Jose. 7. Square root of x squared. Someone. Josie. X. I'm going to multiply these two numbers together and then multiply by 2. 7 times x, 7x. Times 2, 14x. Boom, it's a perfect square. Now that we know it's a perfect square, let's go ahead and use our formula. It's going to be something squared. What goes in our formula? Andres.
Would it be 7 minus x?
There it is. And the minus came from the negative 14. And we're done.
Whatever the symbol in the middle term is, goes to the last term?
Yes. Or it should go in the middle as long as you're doing the order correct, I guess.
So if it was x squared plus 14x, no, minus 14x plus 49, the 7 would be the negative?
Actually, so it's kind of funny because it's the way that you would normally think of it. So I can say that 7 minus x squared is actually the same thing. Oh, sorry. 7 minus x quantity squared. This is actually exactly equal to x minus 7 quantity squared. Oh yeah, tell us why.
Because when you square something, it would be by itself, so negative 7 and negative 7, and then cancel out to 49, and same with the x. The positives.
Yeah, just make sure everyone can see that. 7 times 7, everyone will shout out, is positive or negative? Negative x times negative x is?
Positive.
X times x is? Negative 7 times negative 7 is? They're always positive. Your first and last term are always positive. The middle sign is always going to correspond to the middle sign of the second term. So this sign is always going to correspond to this sign. So these are actually the same. It's kind of cool. Yeah, all right, let's try the next one. All right, first step, example number 3. Your first step is always the same thing, over and over and over again. First step is to Sergio. GCF. There it is. Do you know what the GCF is? It's actually bigger than 1. Here's a hint. What's that last number?
It's 3.
3? Yeah, so the greatest common factor is 3. So I'll go ahead and write it out for us. 3 times these 3 terms. Someone else, factor out 3. Factor out 3. I'm getting the same 3 people over and over. I'm going to get some more people to get in here. Cohen, factor out 3. If I have 75 cents and I have 3 different coins, each coin is worth? No. You calling someone then, Cohen? Say it louder. Oh.
So when you factor out 3 out of 75, that's going to be 25, because 25 times 3 is 7. That's 25x squared minus 30 go in 30, 10 times minus 10x plus 1.
There it is. Yep. So if I have 75 cents in my pocket, I have 3/4, right? All right, so now let's verify. Is this a perfect square? Well, 25, that's a square. X squared, that's a square of 1, that's a square. We have to verify the middle term. I'm going to have to take the square root of each of those to verify the middle term. Someone take the square root of 25x squared. Jenny. 5x. There it is. I'll do the hard part. Square root of 1, 1. Whew, that was heavy lifting. I did the hard work there. Okay, now we're going to multiply these two numbers together. 5x times 1 is 5x. Double that, 10x. Boom, it's a perfect square. All right, so we verified it's a perfect square. Now someone write out our final answer. Try to get someone new if we can. If not, that's okay. We'll go with Charles again.
So, could you round it as 1 minus 5x?
You could, yeah. 1 minus 5x. What else do we need to write? Quantity squared. Jade. 3 in front. There it is. My line went through the 2. I don't want that to happen. And I'll write down the other answer just in case that's confusing. 3 times 5x minus 1. That is also an answer. Oh, squared. Maybe I should have left the square off so people could get some extra credit, but that's my fault. I'll do that next time. All right. And our final example. Number 4. What do we do first? Wyatt.
Factor out the GCF.
Cool. Do you mind letting Jade do that? Since you did it last time?
Okay, it's coming backwards too.
And therefore, when I factor out the 2 is going to give us
36 plus 12x plus x squared.
There it is. All right, let's verify. Is this a perfect square? Hold up number of fingers. 30 square root of 36 is, most of you have it, 6. Square root of x squared is x. Multiply these two together. 6 times x is 6x. Double that, it's 12x. Perfect. Okay, it is a perfect square. Final answer. Andres.
Leading coefficient of 2, quantity squared, 6 plus x.
Done. Box it. And that concludes the notes. All right, so Advanced Ninja Star on 25x squared minus 10x plus 1. What is that going to look like? Advanced Ninja Star, there's the general setup. We have the needles and stuff on the left and the right. 25x squared times 1. I multiply those two together, and I get 25x, well, I guess 25, right? I just do the coefficients. And then I put negative 10 on the bottom. What two numbers multiplied to 25 and also added negative 10? There's only 2. And I forgot to put the 25x and 25x up here. Negative 5 and negative 5 work. Those are the only 2 that work. And then from there, I reduce the fractions. I get 5x and negative 1, 5x and negative 1, and lo and behold, 5x minus 1 is the answer. So it works for that one. Should I do a difference of squares like I was supposed to do yesterday also? Let me do 9x squared minus 36. No, that has a GCF. Let's do 49. Haha, no GCF. Okay. How do I do this one? Well, there is no middle term, so I can say that this is 9x squared plus 0x minus 49. Those are the same things. When I do my Advanced Ninja Star, yeah, you're next. I make this 49 times 9. This is why you don't want to do it. 49 times 9 is 441. So negative 441 and 0. I'll put a 9x, a 9x. What two numbers multiply to 441? It's going to be the square root of 441, whatever that is. 21. I should have known that. So I'll write 21 and 21. One of them needs to be negative. One of them needs to be positive so that it adds a 0, and it is a negative multiplication. Reduce these fractions. Divide top and bottom by 3. I get 3x minus 7 and 3x plus 7, which is exactly how you would have factored that. It's a 3x plus 7, 3x minus 7.